Hey everyone, and welcome. So, we've all heard the big ideas behind blockchain, right? But today, we're not talking theory. We are stepping inside the developer's workshop. We're going to get our hands dirty and look at the actual code, the specific tools, and the real platforms that people are using to build this decentralized future.
So we get the concept, a distributed digital ledger. But how does someone actually build one? I mean, what does it really take to go from a completely blank screen to a functioning, secure blockchain? Well, that's exactly what we're going to break down.
Here's the roadmap for our journey today. First, we're going to see how theory gets translated into actual code. Then, we'll look at how to lay the foundational bricks of the chain itself using a language called Golang. After that, we'll write the rulebook for our blockchain with Solidity. We'll step into the digital workshop with the Remix IDE, test everything in the Ganache sandbox, and finally, we'll see how this whole thing gets scaled up for big companies with Hyperledger.
All right, let's dive in. Section 1, From Theory to Code. This is where the rubber meets the road, where we turn all those cool, abstract ideas into something real and tangible that actually works. Building on the blockchain isn't magic. Every single decentralized app, or dApp, and every new cryptocurrency out there, it all starts with a very specific set of tools. It begins with the code. So let's take a look at the very first layer in that developer toolkit.
So, Section 2, Laying the Bricks with Golang. If you want to build the house itself, the actual blockchain from the ground up, this is often where you'd start.
At its very core, a block is actually pretty simple, but it's brilliant. Of course, it holds transaction data, but the real magic is in two other key elements: its own unique hash, think of it like a digital fingerprint, and crucially, the hash of the block that came right before it. That single link is what puts the chain in blockchain.
And of course, every chain has to start somewhere. That's the Genesis block. It is the very first one, the anchor for literally everything that comes after. And what makes it so special is that it's the only block in the entire chain that doesn't point back to a previous block, because, well, there wasn't one.
So this is how the chain actually grows. You start with that Genesis block. Then, for every new block, you bundle up the latest transactions, you generate a brand new unique hash for this block, and then, and this is the most important step, you link it to the past by including the hash from the previous block. You just repeat that process over and over, and that's what makes the entire chain so incredibly secure.
Okay, on to Section 3, Creating the Rulebook with Solidity. So if we built the road with Golang, now we're going to program the logic for all the cars that are going to drive on it. Now, this slide highlights a really critical distinction. Let's think about it this way. Golang, on the left, is like building the highway itself, the core infrastructure, the pavement. Solidity, on the right, is for building the cars that drive on that highway, the apps and smart contracts that run on an existing network like Ethereum. Two very different jobs.
So what on earth is a smart contract? It's basically just a program that lives on the blockchain and automatically runs when certain things happen. It's like a digital vending machine. You put in the money, you press the button, and the code makes sure you get your soda. No cashier, no intermediary, just rules that enforce themselves. It's the digital rulebook.
And if we pop the hood on that rulebook, it has a few basic parts. First, you have state variables. This is the permanent data the contract has to remember, like, say, your account balance. Then you have functions. These are the actions the contract can actually do, like check balance or transfer funds. And finally, the constructor. That's a special one-time setup function that runs the very moment the contract goes live on the blockchain.
All right, Section 4, the workshop, Remix IDE. So we know the language, Solidity, but where do we actually, write the code? Well, welcome to the workshop. It's a fantastic environment for writing smart contracts that runs right in your web browser.
And the workflow inside Remix is a pretty simple three-step dance. First, you write your code in Solidity. Next, you hit compile. This basically translates your human-readable code into something called bytecode, which is what the blockchain's brain, the Ethereum virtual machine, can understand. And finally, you deploy that bytecode to the network, and your contract is officially live.
But that leads to a huge question. You've written your masterpiece, you've compiled it, it's ready to go, but deploy it where? You're not just going to throw your brand new, maybe slightly buggy contract onto the main Ethereum network with real money on the line, right? Of course not.
And that brings us to Section 5, the developer's best friend, Ganache. This is your personal sandbox, a local blockchain built specifically for safe testing and development.
What Ganache does is just brilliant. It creates a simulated blockchain environment that runs right on your own computer.
So you get all the power and functionality of a real blockchain, but it's in a totally safe, isolated playground. It even gives you a bunch of test accounts that are already loaded up with fake Ether to play with.
Ganache is absolutely essential for developers. You get an instant local network with one click. You get those pre-funded accounts so you can simulate real transactions. It gives you incredible tools to monitor every little thing that happens. And the best part, you can test, break things, reset, and retest 1,000 times without it ever costing you a single real penny.
Now, everything we've talked about so far, Ethereum, public chains, that's all out in the open. Anyone can join, anyone can see the transactions. But what if you're a group of international banks or a global supply chain company? You need privacy, you need control. And that brings us to our final section, Hyperledger, the go-to solution for private, permissioned blockchains for business.
This table nails the why perfectly. On a public chain like Ethereum, participants are anonymous and anyone can join. On a private Hyperledger network, everyone is known and has to be pre-approved. This one change has huge effects. It allows for way faster speeds. And, most importantly, it means you can keep sensitive business data completely private and restricted.
And the biggest name in this space is Hyperledger Fabric. It's an open-source framework, hosted by the Linux Foundation, which is a huge deal. It was designed from the ground up to be a modular foundation for building serious enterprise-level apps, where knowing who you're dealing with and keeping data private is everything.
And this is what makes it so perfect for business. The network is permissioned. You need an invitation to join. You can create something called channels, which are like private conference rooms for confidential transactions between just a few members. A membership service provider, or MSP, acts like a digital gatekeeper managing everyone's identity. And the smart contracts, which are called chain code here, define all the business logic that the members agree on.
So there you have it. What a trip. We went from building a public chain from scratch with Golang to writing smart contracts with Solidity, testing them in Remix and Ganache, all the way to deploying a secure, private business solution with Hyperledger. As you can see, the developer's toolkit is just incredibly vast and powerful.
And that just leaves us with one final thought. We've just taken a full tour through the developer's workshop. You've seen the nuts and bolts, the hammers and wrenches that are being used to build the next generation of digital interaction. So the only question left is, now that you've seen the toolkit, what world-changing idea would you build?